Thank you for assisting our research presentation, a novel VAPT algorithm enhancing web application security to OWASP top 10 optimization. My name is Rui Ventura. I'm master student at Faculty of Engineering Institute Polytechnic of Beja, Portugal. The structure of this research and presentation is made by the following topics: background, literature review, methodology, results, and final discussion and future work. This study explores the benefits of cybersecurity, as well the automation of VAPT tools and techniques for web application security audits, modeling the attack by an optimization of OWASP algorithm. The focus of this research is related to the benefits of the VAPT automation, techniques and tools, by modeling the attack, the audit for web application security. The problem statement, our starting point was based on an observation of a benchmark when we construct that the VAPT takes place in different stages of cybersecurity audits, which requires converting the VA results for threat verification. So there is a need to optimize a OWASP algorithm to make span tests automation more consistent, precise, and target. For this research, we have here a second benchmark who help us on the methodology and the evaluation of the results. Our research objectives based on the main research question is the first one to characterize audit cybersecurity web is automated tools and suitable software tools used for automation audits. The second one is to identify methods and techniques for automation of web cybersecurity audits with pen tests by using VAPT software tools and the tools employed in dynamically auditing for cybersecurity of web applications. The last one, the third research objective, it's to optimize our OWASP algorithm that automates the VAPT procedure through a software tools to address and modeling and mapping the prevalent web application vulnerabilities. The resources used were academic studies, scientific studies, and for our research core, an experiment. The literature review tree, it's another form of visual analysis. The literature reviewed this way make it possible to see their relationship and how the subjects and authors contain similarities through sorry, I passed the slide. As I said, we can see the similarities between the content through the different research keys by this kind of analysis with the research tree. For the summarization of the relevant literature review, in this case for the main research keys, cybersecurity audits, allow us to understand the main approaches, the limitations found in each study, and the comparison with this research. In the end, it allows us to summarize the main ideas. Here, for the body of knowledge, and as VAPT processes main research key, also allow us at the end, based on the main approaches, to summarize the main ideas. For the research core and following the first two examples, in this case for the main research key optimize and OWASP algorithm allows at the end also to summarize the main ideas. Following the summarization and supported by this ladder diagram, this is a method that allows us to assist and combine the ideas and summaries. obtained to the main research keys and the literature review. So will lead us to our theoretical hypothesis, that is the optimization of OWASP algorithm allows VAPT to be automated to precisely and effectively cover the common risks to web application resulting from a practical correlation of VAPT process for cybersecurity audits. This theoretical framework and this section provides information how the study should be conducted to fulfill its initial objectives. And we have the problem statement at the top and the main research guides. We have the secondary data and how is collected this data. We have the primary data based on the experience and the comparison of the data sets with the other. Yes. Anybody can say anything?
Continue.
At the bottom, we have in our methodologic framework the theoretical hypothesis. For the key points of the research methodology, we have this diagram highlighted at yellow, our key points. You use a method based on 2 factors and six treatments. The objective of this method is to describe the independence of checking the effects of other factors and selecting the objects that are representative of the population of interest. Then we have our instrumentation and our laboratory where we get our results and our experience. For the methodology for data collection and analysis, we have here 2 steps. It's based on a black box texting approach. We mapped and modeled the attack and also the analysis based on 8 vulnerabilities mapped from OWASP and NIST. We have, you have cross-site scraping, injection, broken authentication, security misconfiguration, sensitive data exposure, malicious file inclusion, cross-site request forgery, and insecurity communications. The first data set is, like you can see in this diagram, is obtained dynamically with the 7 web application and the tools, and we have all the vulnerabilities in the end. The second data set, it's a manual approach, and it's a re-evaluation of the vulnerabilities that are wrong detected or not detected by the scanners, and the true vulnerabilities detected. Metrics used from the benchmark, we have precision rate, the false positive rate. The metrics introduced by this research was the false negative rate and the detection rates will help us forward to evaluate the effectiveness rate of the tools. In this step, we have here our prototype. Our optimization is composed with 4 models. The VA, who detects the investigated vulnerabilities, the PT, who exploits the vulnerabilities, the VAPT, who combines the 2 techniques and tools, and at the end, you have the reports, who allow us to report all the events and the vulnerabilities, even the debug from the prototype. This prototype can allow us to make a mass attack with all tools, or you can choose a tool and assess all the vulnerabilities maps or model. You can choose a target attack. You can choose a specific vulnerability to investigate or to assess to see if it's exploitable or not. So we are happy with this development. According to the first dynamic collection and results and analysis, we have here the first results in the first data set. As you can see at the first approach, that NetSparker and Zap proxy, they are the highest, who get the highest values on this first approach. We have highlighted here these two applications, W2 and W6. At the moment we collect the data, the application W2 was not available at all, and the application W6 was partially available. Even so, we get it for audit for as good. As we can see, comparing to the benchmark, they have higher values, and then what is one of the reasons they have more hits than we get it in hours to study. Another question was some controversies. We found it also, but our opinion is that in this phase is not important the quantity, but the quality of data collected. Here, in comparing the results and focus on our goal, that is the modulation of the attack with the prototype and the results for the investigation vulnerabilities. As you can see, our prototype was the highest, got the highest values for the mapped vulnerabilities, who demonstrates here that the reflect of the optimization. You can see here also in these two pies the comparison with the benchmark. All the vulnerabilities in percentage was increased except these two, and we have a reason for this. The vulnerability misconfiguration, security misconfiguration, we have 35%, if I'm not wrong. This is due to the proper the way the improvement of the tools and the way they interpret the result, the response from the servers and from the application. So was an improvement from the tools here, and this is our explanation for this result. And for the vulnerability malicious file inclusion, during the collection we got several times blocked by some countermeasures. This was not mentioned in the benchmark, so this is a new fact. And we got lots of so we detect WAFs during the collection who limit us to collect more this vulnerability. And this, as you can see, all the tools have lower results for this vulnerability. For V6 malicious file inclusion, that was to the fact we found some WAFs to block us when we try to exploit this vulnerability. At the end, we have all hits for all the vulnerabilities with the prototype. So once more, it reflects the modulation made by this research. Here for the second data set, the data set was acquired, obtained manually. So it's focused on the false positives and to evaluate the precision rate for our prototype. As we can see here, bottom, it was an update for all the tools except for Nexus with 88. And our prototype got so it separated the initial objectives of this research and got a 92% of precision rate, what gets us very happy too. For the vulnerabilities that were not detected and for effectiveness rate, once more, Connexus was the best. It's playing at home, and I can explain you that better. If you see the full text of the research, maybe you found something. And we got a 96% of effectiveness rate. Once again, who got us very, very happy with these results and the revalidation of the vulnerabilities by the second data set. The contribution for this experience was the automation and model of web security audited, the distribution of audits across several dedicated VAPT tools and well-known tools, the precision rate of 92% for the model investigated vulnerabilities, the effectiveness rate of 96%, and the reduction of false positives and false positives and false negatives, and the offer of usability and accessibility for known and experienced users, for example, and with the offer and integration of user interface access. In brief, two benchmarks were used, two sources of data were analyzed and compared. Our results align with the purposes of objectives, and we contribute directly to the algorithm optimization. This adds value for web VPT audits, the reduction of false positives and false negatives, reductions of costs and resources, helpful for inexperienced users, as I said, in general for cybersecurity audits with recognized international standards. Limitations, we found some limitations in performance of the tool and the precision. Yeah, maybe we have to change some of the tools to improve better precision. The payloads also improve the broken authentication and file inclusion, maybe aid the WAF bypass. It's a good idea. The commercial tools also have a limitation. They don't offer anymore trial versions. They now formerly Inviti, not Aconnect and other next partner. They changed the name. Future work, the research about new automated tools, updating this research for the last version of OWASP top 10, and introduction techniques of machine learning, AI. It's a good approach for the future. And that's it. Our reference, our authors and subjects cited in this presentation. I think I was too fast, but thank you. If you have questions, thank you very much.